Dear second prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Algebra Unit 2, Lesson 2. The lesson is called The Slope of the Straight Line. In this lesson, inshallah, we are going to study the meaning of the slope, and we are going to know the relation between the slope and the angle between the line and the x-axis, and we are going to solve many problems about this concept. Let's start the lesson. First, by looking to this picture, we have here a bridge. This bridge make an angle with the horizontal level or the ground level. This angle depend on an object, a mathematics object called slope. Then the slope control the angle between this bridge and the horizontal level or the ground level, which called x-axis. Then before building any bridge, actually we need to know the reason or the required of this bridge, and then studying the slope and then build this one. Okay, now to know the meaning of the slope, let we have a graph like this and we have a straight line like this. Okay, to study the slope of this straight line, we are going to choose 2 points on this straight line. For example, if we have here point A and if we have here point B. Now I need to study the motion of A to reach B again. Now I need to study the motion of A to reach B. If A is a point like this, if A moved to reach B like this, again like this, okay, this motion, as you see, formed a right angle triangle like this. This right angle triangle, its hypotenuse is the same, the straight line we study its slope. Its base parallel to x-axis, then its base called x coordinate or x change, and its height parallel to y axis, then its height called y change. To measure its base, we count here 1, 2, it's 2 units. We called the base here the base x because it represents the change of x. What does it mean? B, the point B here opposite to 4, and the point A opposite to 2. If we subtract 4 minus 2, it equal 2. This one called change of x. And here, if we count the height, we have here 1, 2, 3 units. This one called y equal 3. Y equal 3. We call this one y because this one represents the change of y. What does it mean? B opposite to 5 and A opposite to 2. To find this one, 5 minus 2 equal 3. 5 minus 2, or the change of y, represent the height of the triangle. As we see here, this is the change of x and this is the change of y. First, now I need to know what the meaning of the slope. The slope equal the change of y over the change of x. Again, the slope equals the change of y over the change of x. Here we have the change of y equal 3 and the change of x equal 2. Then the slope of this straight line equal 3 over 2. Now I explained the first way to measure the slope of a straight line. We have another way. This way is called the graphical representation or the graphical study of the slope. We have another way without represent the straight line graphically like this. For example, if we have the point A, which is 2 and 2, and the point B, which is 4 and 5. We know, of course, that here 2 is x and 2 is y, 4 is x, 5 is y. But to make a difference between them, We call this one x1, and we call the 2 y1, and 4 x2, and 5 y2. As I said before, the slope is what? The slope is a change of y over the change of x. To measure the change of y, we subtract y2 minus y1. Again, to measure the change of y, we subtract y2 minus y1, which is 5 minus 2. To measure the change of x, we subtract x2 minus x1 to give me the change of x, like this. y2 minus y1 over x2 minus x1. This is the change of y, and this is the change of x. Here, 5 minus 2 over 4 minus 2. 5 minus 2 equals 3, and 4 minus 2 equals 2. It gives me the same slope as I studied in the graph, but this is another way without representing this one graphically. Now we are going to study the cases of the straight line. But first, before I explain the relation, okay, I need to mention how I explained or how I measured the slope graphically. The straight line makes y change and x change. Y over x give me the slope of this straight line. If we change y, the value of y, it becomes bigger, then the line makes another angle with the x-axis, like this angle, which called the angle between the line and the positive direction of x-axis. Okay, here if we have a line like this which represent the x direction, for example, this line equal 1, and line like this which represent y direction, for example, this line equal 5. By connect them like this, we have a straight line. This straight line make x change equal 1, y change equal 5. Now if I need to measure the slope, okay, then the slope here equal 5 over 1, because it's 5 over y over x, y change over x change. Okay, as we see here, if I comparison this situation with the coordinate, it will be like this. This is x-axis and this is y-axis. The line here makes an angle with x-axis. Okay, the slope here is a very big slope because 5 is a big number. Okay, if the slope is big, it makes an angle. It probably right angle with x-axis, but it's not right angle, it's an acute angle. Another case, if x here is a great number like this, and y it's equal 6, for example, and y here small number equal 1, for example, now y over x 1 over 6 represent a small number, then the line makes another angle like this. Okay, this in that case the slope equal 1 over 6. We see here the slope here is small, then the line makes a small angle with the positive direction of x-axis. If the slope is big, it makes a big angle with x-axis. If the slope is small, it makes a small angle with x-axis. Another situation, if we have a line like this and y like this, now y in this direction, okay, then we measure x from right to left, then it will be negative direction like this. It will be, for example, negative 4. And y up from down to up, it's positive direction like this. Now we have y is positive and x is negative. In that case, the line will take this direction. Okay, in that case, the slope, it will be negative 3 over 4, or 3 over negative 4, which is negative 3 over 4, is negative number because x here is negative. Okay, the line in that case will take this relation with positive direction x of x-axis. It makes an acute angle with the negative direction of x-axis. Here the line makes acute angle with the positive direction of x-axis because it's positive slope, and here also makes an acute angle with the positive direction of x-axis, so it's positive slope. Here it makes acute angle with the negative direction of x-axis, though, so it's a negative slope. Okay, another situation. If we have a line like this, and this line, okay, by studying its motion, makes, okay, no change, okay, yani if we have a motion on x but no change on y, in that case y change equal nothing, equal 0, and we have any value of x, then the slope in that case equal 0 of over any number equal 0. Okay, in that case the line parallel to x axis, as we see. Another relation, if the line, if we studied the motion of the line to reach this position finally, okay, this, in that case we have here x change equal nothing and y change any number, then the slope equal any number over 0. Any number over 0 is meaningless or undefined. In that case the line is parallel to y axis. Then finally we have the two special cases. If the line parallel to x-axis, then the slope is 0, and if the line parallel to y-axis, then the slope is undefined because there isn't any x change, or we divide by 0. Then we have four cases. If the slope positive, it makes an acute angle with positive direction of x-axis. Okay, if the slope is negative, it makes an acute angle with the negative direction of x-axis, or the line here inclined at the positive, وهنا, and here the line inclined at the negative. Here the line, okay, is not is parallel to x-axis, then its slope equals 0. Here the line parallel to y-axis, then the slope is undefined. Okay, the first example with us, classify the slope of the straight line in each of the following figures, showing whether it positive, negative, 0, or undefined. In the first case, here's a line, as we see here. The slope here inclined with the positive direction is x-axis, then the slope here is positive. The second case, here's a line inclined in the negative direction of x-axis, as we see, then the slope here is negative. The third case, the line here parallel to y-axis, then the line here, the slope here is undefined. Number 4, the line here parallel to x-axis, then the slope here equal 0. It's clear now that the four cases of the straight line inclined on x-axis, on positive of x-axis, inclined on negative of x-axis, okay, parallel to y-axis, parallel to x-axis. Okay, the next example. Here in example 2, find the slope of the straight line passing through the 2 points in each of the following cases. In the first case, here we have x1, y1, x2, y2. The slope equal y2 minus y1 over x2 minus x1. Here the slope denoted by m, equal y2 minus y1, which is 4, minus 3 over 3 minus 1. 4 minus 3 equal 1. 3 minus 1 equal 2. It will be 1 over 2. Another case, 1, 2, 5, 0, x1, y1, x2, y2, then m equal 0 minus 2 over 5 minus 1, it equal negative 2 over 4, which is negative 1 over 2. Negative 1 over 2. Another one. x1, y1, x2, y2, then m equal 3 minus 3 over 2 minus 1, which is equal 0. Here m equal 4 minus 2 over 5 minus 5. It's equal 4 minus 2, 2, 5 minus 5, 0. 2 over 0 is undefined. Okay, now we have positive slope, negative slope, 0 slope, undefined slope. This one inclined on x-axis in positive direction. This one inclined in the negative direction of x-axis. This one makes angle like this. Okay, this one makes angle like this. This one parallel to x-axis. This one parallel to y-axis. And these are the four cases of the slope of the straight line. Let's solve the next one. Here in example 3, if the slope of the straight line which passes through the 2 points 1, 3, 3k is 3, then find the value of k. Okay, here we have x1, y1, x2, y2. Okay, then m equal, or the slope equal, k minus 3 over 3 minus 1, which is equal k minus 3 over 2. Here the slope equal 2, equal 3. Then k minus 3 over 2 equal 3. Okay, here I can represent this one 3 over 1. Then I will make cross multiplication. How come? 2 times 3 over 1. Again, 2 times 3 over 1. Then k equal k, I'm sorry, k minus 3 equal 2 times 3 over 1. 2 times 3, 6 over 1 equal 6. By sending minus 3 there as plus 3, then k equal 6 plus 3 equal 9. This is the value of k. The next example, example 4. If a equal negative 1 and 4, b equal x and 2, find the slope, and the slope equal negative 2, then find the value of x. Okay, here we have x1, y1, x2, y2. Okay, then m equal 2 minus 4 over x minus 1. It equal 2 minus 4 equals negative 2. X minus 1, it x minus will be plus 1. Okay, and m here equal negative 2, therefore negative 2 over x plus 1 equal negative 2. I will make it negative 2 over 1. Then x minus 1 equal negative 2 times 1 over negative 2. Again, negative 2 times 1 over negative 2, then x plus 1 equal negative 2 times 1 equal negative 2 over negative 2 equals 1. Here I'm going to send 1 there as minus 1, then x equal 1 minus 1 equal 0, and this is the value of x. Now we are going to study two special cases of the straight line like this. If we have a graph like this line parallel to x-axis, this line, the slope equals 0, as we said before. The slope equals 0. Okay. By choosing 2 points on the straight line, A here and B here. Okay. A equal, as we see, 1 and 2. B equal 4 and 2. Which is x1 and y1. B 4 and 2, which is x2, y2. By studying the 2 points here, we found that 1 and 2, 4 and 2. Okay, we found here that y1 equal y2. Again, y1 equal y2 when if the line parallel to x-axis, then y1 equal y2. It's a very important remark. Another case. Okay. If we have another 2 points, another straight line like this line in that case parallel to y-axis. Okay, if I choose another point C here in this position, which is 4 and 5, and the point D here, which is 4 and 1. C equal 4 and 5. 4 is x1, 5 is y1. D is 4 and 1, x1, x2, and y2. Okay, here by looking to the 2 points, we get that x1 equal 4, x2 equal 4. Then they are equal to each other, x1 equal x2, when if the line is parallel to y-axis. Again, if the line is parallel to x-axis, then y1 equal y2. If the line parallel to y-axis, then x1 equal x2. Don't forget this special case. It's very, very important. Okay. The next example with us. Here, find the value of k such that the straight line passing through the 2 points 3 and 4 2k parallel to x-axis. Okay. If the line here parallel to x-axis, then we get that y1 equal to y2. Again, if the line is parallel to x-axis, then y1 equal to y2. Then we get that y1 equal to y2, then k or 4 equal to k. This is the value of k. Another one. Find the value of x such that the straight line passing through the 2 points 2x and 3, 6 and 7 parallel to y-axis. Here, parallel to y-axis, then x1 equal to x2. Okay. Then we get here 2x equal to 6. Then because x1 equal x2, to x equal to 6, then x by sending 2 there divided by 2, then x equal 3. This is the value of x. Okay, the next one. Prove that the points A, B, and C are not collinear. Okay, what's the meaning of collinear? The collinear means 3 points on the same straight line. Okay, if 3 points lie on the same straight line, then the slope here m1 and the slope here m2 are equal. Okay, if to prove that the 3 points A, B, and C are not collinear, then we need that to prove that the slopes are not equal. Okay, the first one, we are going to take the slope of AB and the slope of BC. Okay, slope of AB equal 0 minus 1 over 3 minus 2, which is equal negative 1 over 1, which is equal negative 1. And slope of BC equal here equal negative 1 minus 0 over 5 minus 3, which is equal negative 1 over 2. Okay, therefore slope of AB doesn't equal slope of A, of B, C, then the two straight lines are not, the 3 points are not collinear. The next one, A equal negative 1 and 2, B equal 3 and 1, C equal 7 and 2. First, I need to find the slope of AB. Of AB equal 1 minus 2 over 3 minus 1, which is equal negative 1 over 4. And the slope of BC equal 2 minus 1 over 7 minus 3, which is equal 1 over 4. Here, therefore, slope of AB doesn't equal slope of BC, then they are not collinear. The next one, example 8. Using the following graphs, find the slope of the straight line L in each of the following cases. Number 1, here we have straight line L. To find the slope of this straight line, we need 2 points on the straight line. Okay, the first point here, this point is 1, 1. The second point is 0, 0. The first point is 0, 0. The second point is 1 and 2. Then M equal 2 minus 0 over 1 minus 0 equal 2. Another case. Here the line passing through 0. The first point is 0, negative 1. And the second point here, negative 1 and 1. M here equal 1 minus 1 over negative 1 minus 0, which is equal 2 over negative 1, which is equal negative 2. And this is the end of our lesson. I hope it was helpful for you. See you in the next video, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.